Hello, my name is Suraj and my friend Kevin. We both are going to walk you through this presentation. This is our final presentation for machine learning project of spring 2020 semester, which is famous for coronavirus. Just kidding. Our project is real-time object classification using deep learning. In this presentation, we are going to show you and describe the features of our application that we built. Code can be accessed from GitHub. Link will be provided in the description. Project summary. This project's aim was to implement a model that classifies with almost perfect accuracy and very low latency inputs from a video camera. Our focus was initially on real-time dog breed classification. We later added real-time cat breed classification since we had enough time to add features and gained enough knowledge to make improvements. We have built a model that classifies breeds with a more or less acceptable accuracy and latency for dogs and cats. Note that our model is as good as the training data. For the purpose of this project, we used the Coco dataset combined with the Stanford Dogs dataset for training the model. For cats classification, we used Kaggle Cats dataset. Targeted functionalities: splash screen, main user-friendly interface, autofocus image stabilizer, high accuracy performance, real-time dog classification, real-time cat classification, and a toggle switch between dog to cats and cats to dogs classification. Implementation process. There are three main UI layouts in our project. The first step in our implementation was to start with the layout XML files, then moving to authorizing and accessing the camera from these fragments. The next step is then to train our model using the Firebase ML kit and implementing a classifier activity that captures and feeds multiple image frames at a fast pace to our model and displays the output in a text view. This is how we achieve real-time image frames classification. Thank you. From here on, my friend Kevin is going to take over the presentation and continue.
Hello everybody, my name is Kevin and I'll cover the rest of the presentation. So here on the screen we have the accuracy and the confusion matrices for our two models. We trained two different models for cats and for dogs. For our cats model, the average precision is 56.36%. So this has an explanation. I will explain it further in the demo why that accuracy is kind of small compared to the dogs model. In fact, the dogs model has an accuracy of 93.15%, which is very good. On the confusion matrix, we will notice that on the yellow dots we have the percentage of confusion, meaning the percentage of similarity, or how easily the model is able to differentiate between two different breeds. The blue dots are basically the breeds with itself, so these are supposed to be 100%. We can notice that in the dogs confusion matrix most of them are 100%. On the cats confusion matrix, on the other hand, we have a lot of yellow spots, meaning the model is getting confused sometimes between one breed and another. Let's move to the next slide. Future work. So our work can be extended in the following various axes. So we can build further enhancements of the model's accuracy and speed for an almost null error rate. We've just seen that the cat model is not very reliable. Again, during the demo we'll explain that it has a scientific explanation. And number two, adding more supported animal spaces. The ultimate goal would be to implement a universal pet and wild animal real-time classifier. So that will be the ultimate goal. It will be to have a mobile application which can basically classify all type of animal you might see in the wild or in households. Number three, expanding these projects to multiple platforms other than Android, iOS wearable devices, and smart TVs. So now we have wearable devices equipped with cameras. So this model this project can be expanded to these different platforms and to TVs, which are very common in homes. So now let's show a short demo of our application. Welcome to our demo. Here we're gonna test the accuracy of our application. So without further ado, let's start our application. Here we have the splash screen and the main interface. Let's start with dogs. So this is a Saint Bernard, and let's see if we can, yes, Saint Bernard, this is correct. So let's move to the next dog. So this is a Manchester Terrier. Okay, let's see if we can get it more accurate answer. No, I think we got Labrador Retriever, which is not correct. Let's move to the next dog. This is a Dalmatian. Yes, Dalmatian, this is correct. So let's move to the next dog. This is an Akita or Shiba Inu. Sometimes people call it also Shiba Inu. It's a Japanese dog. We have the correct breed. So this is a Afghan Hound. Let's see if, yes, Afghan Hound, found the correct breed. And now we have cats, so let's switch to the cats. For that we'll have to press here. This tells you which classification is it. So now we turn to cats. Yes, here we have the cat classification. So this is a tiger cat. Here we have a ragdoll, which is not correct. Okay, let's move to the next. So here we have also a ragdoll, which is not correct. So let's move to the next one. We also, we have a tiger now. This is still not correct. Tiger was a previous breed. This is an American short hair. And we're getting a ragdoll, which is not correct. And this is an Abitian cat. Oh, the American short hair was the previous one. This is giving us ragdoll. Still incorrect. So if you've wondered why the cat classification was so unsuccessful, it's because in fact cat breeds look very similar compared to dog breeds. So I would advise you to read this article of Business Insider. So basically it discusses why dog breeds look so different but cats don't, because cat breeds kind of still look similar, which make them more difficult to classify. So I would suggest this article is a good read if you wonder why our cat classification was pretty much unsuccessful compared to the dog classification. So this was it for our demo, and thank you for tuning it until the end. Research references. These four main papers inspired our research and our project. So we have Look Closer to See Better, which is a very nice paper which I recommend. And the second one is also very nice. It mostly discusses how to build a convolutional neural network for birds, and so do the two others. The last one is actually focused on dogs. So both of these 4 papers are very nice, and I would recommend to read them. So that will be all for our project. Thank you so much for tuning up till the last slides, and we hope you like our project. And if you like it, it's an open repository, so feel free to clone the repository, feel free to add code, feel free to enhance this project. And if you need any support or any maintenance, feel free to contact us through email addresses. Thank you so much. This was Kevin and Suraj. Thank you.